Okay, so good morning, everybody. Assuming you're in the same time zone as me. My name's Johnny Cheetham. I'm based in Neo4j's office in London. And I'm just going to take you through a short tour through Neo4j, kind of with the assumption that you're not yet very familiar with the product. That this is one of a series of webinars. We do one every week. Covering various subjects, and I hope this will intrigue you and that you'll come back for more. Let me start by just saying a little bit about Neo4j, the company. So Neo4j has been around for nearly 15 years, and we are kind of unusual for a venture capital-backed graph database, in that the guy that wrote the first line of code, Emil Ephraim, is the CEO today. So what that means is that although we have borrowed money from venture capitalists, we've always kept our promises, and Emil has been supported by the investors to keep the company going, and that's actually quite unusual. So what has he built? What have we built? So first of all, Neo4j is a database. So it's a database in the sense that Oracle or MongoDB are databases. It's a place to store data and to process data, but it has some very special characteristics. And the first word I'd like to draw your attention to on the slide is the word native. So it is a native graph database, and what that means is that we control everything about it, right down to the storage format on persistent disks. So we're not sitting on top of somebody else's data storage. We've written the whole stack ourselves. I'll come to why we did that in a moment, but let's just talk about what the thing is. It's a high performance, it's an ACID. What ACID means is it's transactionally aware. So if you write something, you're sure it's written, and it's got the opportunity of rolling back things if you decide to abort a write in the middle. So it's a kind of a traditional database in that sense, but it becomes different from a traditional database and more like other NoSQL databases in that it's got a very flexible schema. And that means it's incredibly good for modeling real world problems without the issues of transformation that you see with some other platforms. Now, the next thing to say is it's been developed by engineers for use by engineers. So it's a very friendly, easily managed, easily maintained environment that anybody who's worked in a DevOps environment will feel very at home with. The next point is that we talk about hardware efficiency. So we've got an example customer, which is Adobe, who are running an application which they first implemented on Cassandra, and that application required 130 servers to deliver the functionality to their user population. They then thought, this is ridiculous. We can't use 130 servers for something as simple as this. Let's see if we can re-engineer it. And they chose another tool. They chose to re-engineer it in MongoDB, and it took 50 servers to do the same job. And they were pleased for a moment. And then they thought, well, this is still costing us far too much. Why is it requiring so much hardware? They re-engineered it in Neo4j, and it's running today, giving better performance on 3 servers. So I'm not saying you'll get that level of efficiency for every application, but Neo4j is a super efficient, high-performance database. We talk about global scale, so we're represented everywhere in the world, and we talk about graph adoption. And Neo4j, I think, whatever else you say about it, has been very instrumental in getting graphs onto the radar. We have a community edition of the product, which is extremely popular and very widely used. So let me just talk a little about Neo4j, the company. We're just under 300 people now. The company was originally founded in Sweden, and all the engineering is in Sweden or in London. But the headquarters now are in Silicon Valley in San Mateo, and that's where the sales leadership are based. But it's still run by Swedes, so it's got some Swedish characteristics. As I said, it's a venture capital backed company. So most recently we had a big investment from Morgan Stanley, which we think is a significant, not just as an investment, but from an endorsement from one of the markets that we attempt to address. And if you look, you can see that we have been very successful with financial firms. And in the ones that are using Neo4j, very, very often they're using it for multiple uses. So there's lots and lots of Neo4j being used. I'll also draw your attention, I don't know who in the audience is from a software vendor rather than a user, but Neo4j is used in an OEM context, so it's built into lots of other products. So products from HP, for example, products from Ericsson, for example, have got Neo4j built into them. And if you look further over, you can see some of the users that are using Neo4j today, and hopefully you'll recognize those names. Right over on the right, some of the partners, and I'll just draw your attention to the fact that we're available through Google Cloud Platform, Amazon Web Services, Azure, and other of the standard web platforms that everybody's using. So why did Neo4j come about? Well, Neo4j came about because somebody had a problem organizing a hierarchy. It was kind of a product hierarchy. They implemented it first on a relational database, and it was terrible performance and very, very difficult to code. They then implemented it as a graph model on top of a relational database, and that was much easier to code and quite delightful, but still gave terrible performance. And then they thought, well, wait a minute, this is a problem that everybody's seeing all over the place. Let's build a tool for the job. So that's why they started building Neo4j. And at that time, there were a few other significant things happening in the world. So Google was getting its act together, and other big graph-based applications like Facebook and Twitter were getting their acts together. So the world was moving towards graph. And it's really interesting to think of all those huge companies that have changed the landscape so much, which are based essentially on the graph technology that we're making available to people who don't want to do as Google did and don't want to write their own database. So what we're doing is saying that the secret sauce that made Google a successful company is something that's going to be valuable for lots of applications, not just for social networks. And we're making it available kind of as something you can download and get using very, very quickly. And that's driven really by the fact that not only, as everybody knows, is data exploding, but if you look slightly harder at that data or look at it in a bit more depth, you'll realize that it's the connections between the data that are really, really significant. So when we all started carrying mobile phones around and using tools like WhatsApp, it wasn't just that there was another mobile phone for the WhatsApp developers to worry about. Suddenly they had to worry about all the connections that that person had with all the other WhatsApp users in their various groups. So each individual device is growing at huge rates and contributing lots of data, but also massive connection issues or connection opportunities, we would say, are emerging because of the way in which technology is enabling communication in every sense. So I'll just give you a moment to look at the networks of people, business processes. So we see a lot of people who are using it for example, for data lineage type of applications, but also for fraud detection and things like that. And we'll talk about those in a bit more detail. So from this slide, just take away the idea that there are lots of the proliferation of data also leads to a proliferation of connections between data, and Neo4j is a tool that helps you to deal with that. So we're talking about those connections between data. So Neo4j is designed for dealing with that connected data. So what this slide that you're looking at the moment shows us is that different databases have got different levels of ability to cope with this challenge. So traditional databases, or when we talk about traditionally relational databases, have got the ability to do what we call join operations. So you can traverse data within the database, but realistically, you can't do that for very many. And if you're writing a high performance application on a relational database, the first thing you learn is don't do joins. If you're not in such a challenging environment, you may use joins, but you won't be able to get very far if you want to traverse very many. And if you think about a telco network or a social network or many of the other networks out there, 3 joins is not very many at all. But of course, the world's changed not just with graph databases, but lots of other databases. So the data lake family of technologies, Hadoop-based, but also the document databases and the wide column databases. They're all relatively new, but they don't actually help with this particular application because the database itself doesn't know about the connections that exist between the elements in it. So all of the referral across between elements has to be done at an application level. The database doesn't help you at all, which means you get poor performance, and also your application program is very complicated. With a graph database, what we're looking at is something that can cope with literally millions of hops between data elements. That results in some fantastic user stories. So at the bottom there, you'll see one of our users at eBay. Our Neo4j solution is thousands of times faster, and the queries require 100 times less code. So Neo4j is very, very efficient and fast. It's also very efficient from a code creation point of view. So your queries are short, concise, and easy to maintain. So what is a graph database? Let's just talk about the graph model for a second. It couldn't be simpler. A graph model consists of nodes. So you can see the person and the car here. They're nodes, or the 2 people in the car are nodes. Nodes connected by relationships. So there's the married, there's the drives, there's the lives with. These are relationships. And both nodes and relationships can have properties associated with them. So you can see the properties like the brand of the car and so on. So this model is very, very simple. What it's basically saying is things connected to things. And if you're a data modeler, you can't imagine any problem that cannot be easily modeled with a model that supports things connected to things. The world itself, the real world, is made of things connected to things or things related to things. And our model allows you to do that. So the difficult exercises of normalization and trying to map the real world problem onto tables with rows and columns just disappears, and all the compromises that the designer has to make in dealing with that, they disappear too. So we've got an extremely simple data model. It comes with a query language that reflects the data model. We call our query language Cypher, and that makes it extremely simple to query and to get very good results out of the database. So how's it working? How are people using it? What's it doing? So there are 3 classes of application that I'll draw your attention to. There's the data journalism, or what we call graphs for good. What people are doing. So if we're looking at Panama Papers, for example, Panama Papers, you may remember being a major public news story. In fact, the journalist that worked on it won the Pulitzer Prize, and it resulted from the theft, in fact, of some data, which I'll show you in a bit more detail later on, which resulted in the resignation of the prime ministers, not just of Pakistan and Iceland, but the investigation of politicians across the world for defrauding their populace. And we'll talk a bit about how that happened. So also on Graphs for Good, NASA is a big user of Neo4j, and it's not us that say this, it's NASA that say this. That NASA say that the benefits of the data that they've put into the Neo4j database will put a man on Mars 2 years sooner than they would otherwise have been able to do. And I can talk about how that has been achieved, but we'll have to do that offline because we haven't got time today to do that. But what NASA have done is build a very big database of all the things that have ever gone wrong with any of their missions, which is searchable in a way that means that they can anticipate and avoid problems in future planned missions. And finally, Neo4j is very heavily used in life sciences and biology, molecular biology and genetic biology, for modeling genes and phenotypes, and for working out the effect of different drugs and different molecules on different diseases that affect different types of people. So it's really at the height of personalized medicine and of drug discovery. And there are a large number of people using it for that. And I'll talk a bit about a diabetes project that is using the same type of approach. Okay, moving on. So there are three big value propositions for Neo4j. The first is real-time transactions. So Neo4j, as I said, is an ACID database. It's a high-performance database that's often used behind complex applications which have got thousands or millions of end users, and it's got to give lightning response to queries. So the problems where you see this are real-time fraud detection, real-time recommendations, IoT type of applications, and so on. So that's using Neo4j as a real-time transaction-orientated database. But it's also an analytic database. So it's used for things like Customer 360 and single customer view. It's used for, as we said, with NASA knowledge graphs, but also for data lineage and other data analytic type of problems. So there are a number of use cases where people are using Neo4j for making sense of the data that they've moved to their data lake, so that they can begin to leverage the investment in Hadoop. And finally, for business processes, some of these are also real-time, some maybe not. So identity and access management is a big one, where you need to very quickly, when somebody logs on, be able to work out what resources they're allowed to access. Network management is clearly a graph type of problem, so people are using it. Some of the biggest telcos and teleco equipment manufacturers are using Neo4j for service assurance, for capacity planning, for inventory management and things like that. And similarly, if you think of a supply chain is a linked graph, and Neo4j allows you to do analytics. There are a number of people doing carbon budgeting and supply chain reporting for ethical compliance using Neo4j. Neo4j's gathered a fair amount of attention, so I won't read this slide in detail, but if you look at the Bloor report at the bottom, because we've been around a while and because we've got the most momentum of all the graph providers, Bloor are able to say that we're the Oracle or the SQL Server of the graph database world. Well, I talk to lots of people who wouldn't like us to be the Oracle. We don't behave like Oracle, but we are certainly the kind of the solid choice. I think the quote from William Blair, which is a financial analyst, is interesting as well, that of all the NoSQL models, the graph is the one that offers the most distinct value, and therefore is the one that's most likely to survive and prevail. So, and just at the top from Forrester, Neo4j dominates the graph market. So let's just talk about the graph platform. What is it? So if you look in the center, you see the blue disk, that's the database itself, but it has two aspects, as we've talked about before. So it's got a transactional view. So if you're looking to the left of the blob, you can see graph transactions, and that's usually sitting behind APIs and drivers with your end user applications and UIs hitting it to provide a kind of OLTP type of service. But on the other side, we can see graph analytics. So that's got graph algorithms and data scientists and people who are trying to explore data. So the use cases for this are maybe forensic investigations, forensic accounting, or forensic policing, or also data analysis. So we've talked about data lineage and those sort of problems where people need to explore the graph manually. And we've got tools to do that. So we've got visualization and discovery tools for helping that. And we've also got a lot of analytics tooling for automatically detecting patterns in graphs. Okay, so that's basically what we're looking at. And just to position it against some of the other databases, you may be aware that relational databases use the concept of data normalization, so trying to separate out different concepts and store them in different tables, so that the data related to different concepts in different tables. And that's a very clean way of modeling, but often gets compromised in implementation where you denormalize. In fact, the reason people do that is to avoid join operations. And then it gets closer to NoSQL databases, which are basically aggregate based. They're just storing lumps of data with different levels of access and different levels of fine granularity. But Neo4j is completely different from that. Neo4j is super normalized. There's never any need to repeat anything in Neo4j. It's all, each data item is stored individually with no repetition, no null values. And the relationships between the concepts is very cleanly represented. So it gives you a very clean model with very high performance and very efficient. So where do we find it being used? Well, people do just load data from relational databases if they find that their queries are running too slowly and they can't necessarily do the queries they want in reasonable time. People will often load data where you've got recursive queries or multiple joins. Just load the data into Neo4j for answering those specific queries. And then what we find is that people start doing more and more of the work in Neo4j. So that's a perfectly legitimate use case, and we see that not just from traditional tools, but also from Spark and other tools where which are designed for analytics, but the basic view is tabular, and sometimes you want to have a graph view of the tabular data. So that's a very common use case, and that's often included in a larger version of that, where you're actually looking at data at Neo4j as an integration layer, either copying the data also into the graph, that's very common, or just holding pointers into the source systems within the graph. So the graph holds a kind of dictionary for helping you to access stuff in the lower level. That's common use case as well. And finally, and I've mentioned this before, it's providing a way of helping you to get value out of your data lake. So I mentioned before using Neo4j as a dictionary into data lakes, but also where your data lake has got too much latency and you need to start doing real-time operations against it. Neo4j is a great way of finding the patterns and then building almost a cache for doing real-time transaction serving. I mentioned, if you remember the picture of the overall schematic of the system, there was the analytics area on the left. We're very proud. We've just published a book which has had an extremely high rate of downloads. You can get it for free on our website, Graph Algorithms by Mark Needham and Amy Hodler. And these are server-side algorithms that you can run against Neo4j or against Apache Spark or in combination. And if you look at the main part of the slide, there are 35 algorithms that are grouped into complex weighted path finding, centrality, so that's things like PageRank and other centrality algorithms, community detection. So if you're looking at a large number of transactions, you might be able to, by analyzing the way the transactions are linked to each other and to other data items, you might be able to detect that actually within your community you've got different demographics. You might have males and females, you might have people of different ages or different interest groups. And by being able to analyze the connections between the data, we can propose the separate communities that will help you understand the population you'll deal with better. Link prediction, so that's something that's very common in sort of crime fighting and things, where you've got two people who've got something in common. Perhaps they've got a crime in common, or perhaps they've got some other relationship, and you can predict that these two people, although they're not previously linked, should be linked together. So, and because we've got the, if you remember back to the model picture, we've got properties that we can store in relationships. We can store, for example, a confidence level along with a link prediction. So we might be able to say that somebody is 90% certain to know somebody else, for example. And then similarity, so it mentions they're looking at similarity between nodes. Even more interesting is similarity between paths. So if you're looking at analyzing paths across a website, that you can train the database to recognize which paths lead to happy outcomes and which paths lead to, I don't know, basket abandonment or other unhappy outcomes, and then see what the characteristics of the two types of paths have, and see if you can do something to increase the number of people with the happy outcome. This is just drawing attention to the fact that we've got an end user visualization tool. Neo4j, when you download it, comes with a browser-based visualization, so you can download the community version of Neo4j and get going immediately with a browser-based visualization. But that's really designed for developers who are happy to learn the Neo4j query language, this Cypher language I've mentioned. We've got another product which is called Neo4j Bloom, which is designed for end users who don't want to invest the time in learning Neo4j, but do want to get straight in and start exploring the data and running the algorithms and using Neo4j as end users. So this has got a kind of natural language interface, which means that you can make a lot of progress very quickly. Okay, so let's talk about how people are using Neo4j. The main use cases. So this is more of a heat map. There's a lot of cross-pollination between these use groups, and there are a number that aren't on here. Real-time recommendations we've talked about. You know, if you're operating a big retail website, for example, the value of getting the right recommendations onto a web page that's in front of somebody's eyeballs cannot be underestimated. If you can increase just by a small percentage the amount of the chance that somebody will act on a recommendation, then the value to you is immense. It's your only chance to get to sell something to somebody other than the thing they came to your website for in the first time. So it really ups the basket value, and the science behind that is, as you can imagine, very complex and very, very suited to a graph. Fraud detection is another great example. So I'd like to talk about this in more detail, but just for the moment, if you're trying to defraud somebody, you can just be brave and try and get £1 million out of somebody's bank account. But most banks and other services have got wise to somebody knocking on the front door and trying to break in through the front door and steal things. So they've got basic checks. Now, the criminals, in order to get around those basic checks, decide that since there's a point at which a fraud is too low value to be worth pursuing, so they try to do frauds that are too low value to be detected by the basic detection. The trouble with that, of course, is that if you're a fraudster, you don't make very much money out of these low value frauds, and it's not going to pay for your yacht. So you then need to start saying, well, okay, I'm going to have to do this at massive scale, and doing it at massive scale inevitably involves building some connections. So you might be thinking about fake identities, but those often need to have some real identity. So there was a case in the news recently in the UK of a house which had over 1,000 people apparently living in it because it was being used by fraudsters as a false address. And actually, that's a very good example, because that's exactly the sort of thing that you can detect using a graph, because that means there's a pattern between transactions that apparently are unrelated. So all these low-value transactions that are going under the radar of the normal detection, they're leaving a trail, and that trail is a graph, and Neo4j can help you to detect that. So I won't talk through the rest of these examples in a lot of detail because we haven't got very much time, but master data management is a good one. So that's where you've got multiple products, multiple channels, multiple offerings, and you need to form a single view of your customer, or alternatively where you've got complex product hierarchies and you want to have a uniform product hierarchy. And if we have time, we'll talk about eBay using Neo4j in that way. The knowledge graph is a great example, and behind that we probably place most of the very large life sciences examples. So we'll talk a little bit about those going on. And identity access management we've talked about. So these are some of the people who are using Neo4j for these types of use cases. Itaú, if you're not familiar with it, is the biggest bank in Brazil. So I said I'd come back to the Panama Papers. So this was, as I said, it's a Pulitzer Prize-winning effort. It resulted in some pretty big real-world news stories, a scandal around Messi, the footballer, but even more significantly, big political scandals in a number of countries. And so the way these people, what happened was a disk was stolen. And that contained all sorts of things. So it contained fragments of databases, log files, bank statements, emails, PDFs, all sorts of things. And that left the journalists scratching their heads to say, well, I'm sure this is valuable, but what's it telling me? So they used some scanning software, and they started to identify, looking for names. And from names, they were then, because of the nature of the data, able to identify bank accounts and banks, but then they were also able to start looking at street addresses, and that began to give them some clues as to who else was there. So in this case, the story of the Prime Minister of Iceland. Prime Minister of Iceland was at the time of the great financial crisis in the late 2000s. Iceland set up a distressed asset holding company. And he knew which of the distressed assets were very distressed and which ones are less distressed. But he knew he couldn't act on that because it would compromise his job. However, he made the mistake of telling his wife about it, and it became clear that his wife, who lived at the same address, had a different name, but lived at the same address, could be linked to him by the Neo4j database. And that gave them the clue that they needed. So she had a holding company that was investing in this distressed asset company. So that was the way that that fraud unfolded. And there are similar examples all over the place. So this is, Neo4j is doing a little bit of magic and creating relationships between things that you didn't necessarily know were related. So, sorry, I skipped on. So we built the data model from that. So you can see in the database, the model, these colored blobs are very like those real world entities. And we've got the nodes and relationships that we described before. So this is an example of the physical model being exactly the same as the conceptual or the business model. So that's a huge advantage for anybody who's trying to explain the system to a business person, or trying to maintain it, or trying to maintain some sort of fidelity between the business problem and the data and the technical solution. So we're running out of time, but let's just look at some other use cases rather quickly. So we've talked about real-time recommendations, and this is Walmart. So the point I like there is that these are complex transactions, 22 hops in some cases. They're extraordinarily fast, so very low numbers of milliseconds, which is fast when you consider the number of number of transactions, 35 million a day maybe. And as a result of this, because IBM WebSphere e-commerce server was unable to do these real-time recommendations, in this case the company's Target, another big box retailer in the US, are using Neo4j for their recommendations. Marriott are using Neo4j, also replacing a big, very expensive Oracle database to do real-time room pricing. So this is the sort of room pricing that when Madonna announces that she's doing a tour, or when some real-world event happens, a flood or a strike or something that changes the number of people visiting a city, you need to be pretty fast to get your pricing right, or you could miss some revenue, or you could be left with a lot of unsold rooms. So there's a lot of effort and thought goes into this sort of pricing, and it turns out that a graph structured algorithm is the best way to do it. And finally, we talk about DHL. So this is in fact in Germany, where Neo4j is used for routing all of the parcels. And so this is a very real-time application, routing all the parcels that are shipped around the country and via airports around the world. And this is dynamic as motorways snarl up, or airports get put out of action, or flights get cancelled. Real-time routing of very, very large numbers of packages. Just the last few slides now, we're just talking about a couple of detailed use cases. So this is an Internet of Things use case. So Xfinity from Comcast is their intelligent home hub, which is carrying all sorts of data. So it's not just your internet and voice over IP, but also cable and maybe home security and video and your Nest implementation and so on. So all of this gets implemented, gets stored in a Neo4j database, which gives content recommendations and helps Xfinity to understand its customers better, or Comcast to understand its customers better, and to give them a better service. Next, we'll look at something from the financial world, the Thomson Reuters knowledge graph. I think it's now called Refinitiv, which this is very interesting. So what they're doing is providing a service to investors, which helps investors to understand the supply chain of the companies that they're investing in. So if you have a news event, so this is scanning news stories and creating a knowledge graph based on the news stories. You have a news event that affects a company, you and all your other competitors in other investment companies will get that news story at the same moment, more or less. But the person that understands the implications of that news story in terms of what it means for the competitors of the firm, or for the suppliers of the firm, or for the customers of the firm, will be the ones that are ahead. And that's what Thomson Reuters have mapped in this knowledge graph. So it's kind of an impact analysis use case, which allows you to understand the way in which a news story might affect your investments. We're going to talk about the eBay shop bot. So this is something that's been running for a while, first on Amazon, but now, first on Facebook, but now on for their Google e-commerce. So Neo4j is providing a tool for natural language understanding. And if you think about a sentence in any language, that sentence has got a subject and a predicate. It's got potentially adjectives and all sorts of things as part of the predicate. So that is a structured thing. And in fact, it's very commonly modeled as a graph. So Neo4j can help you to structure and understand input sentences, whether it's text or voice or whatever. And then secondly, there's a knowledge graph. So we're not only helping them with the understanding, but also with finding products in their catalog that match the request. And there's a very nice video if you want to spend some time on our website showing how eBay are using Neo4j to improve searches. So I think this is finally This is another fantastic story. This is a cooperation between a lot of research centers in Germany who are using Neo4j to pull together information from dozens, in fact over 50 databases all across Europe, helping to form a more and more complete picture of the different forms of diabetes and the way in which they react to medicines and different therapies. So that's a great story, and again, there's a very good video on our website that where the scientists who put this together talk about the reasons they've done it and why Neo4j has made it possible to do things that they couldn't do with their previous graph implementation. Okay, that is the end of the presentation. So it took most of the time allotted, but we've got a few minutes left for questions, if anybody's got any questions.